Okay, so yesterday we talked about what the solution to a linear system represents. It represents the point where the two lines cross on the graph. But it can get really tedious having to graph these equations every single time. And all of the ones that we did in class, they crossed at a nice, neat, ordered pair. But you can see that when you graph lines, they don't always meet up exactly perfectly. So your solution is really going to be an estimate when you start having to guess, is it 3.5 or is it 3.6 or things like that. So luckily for us, there's a better way to solve it. We can solve these algebraically. We're going to learn two different methods, and the first one that we're going to look at today is solving by substitution, okay? The steps that we want to follow are these. One, we want to solve one of the equations for one of the variables. Now, that doesn't mean solve it and get an answer. That means that we either want we want one variable to be by itself. When we say solve it, that means get x or y by itself. It doesn't matter which one. I would do whichever one's going to be easier. And I'll show you what I mean. But we want to get x or y by itself. The second step is once we've done that, this is why it's called the substitution method, we're going to take whatever it was that we got by itself and plug it in for that variable in the second equation. We're going to get a number this time. And then once we know that number, we'll plug it back into one of the other equations, and that's how we can figure out the answer to the second variable. And then just like before, we're going to write our answer as an ordered pair. Now that's really confusing until you actually see it done. So let's take a look here. Example 1 is really, really nice because it's already solved for one of the variables. Y is already by itself. So here's what we know. We don't know what number y is equal to, but we do know that y is equal to 3x plus 2. So what we do then is in the second equation, I'm going to take out the y and I'm going to replace it with 3x plus 2, since that's what y is the same as. So here's what this first x is not going to change because we're not doing anything to x. Plus 2 times. Now I'm taking all of this stuff and plugging it in for y instead. So I'm going to take out the y and I'm going to replace it with 3x plus 2. And then continue the rest of the equation like normal, equals 11. Now let me just one more time make sure you understand where this is coming from. This used to be a y right here, and that's what we discovered that this was equal to. That came from this top equation here. Y is equal to 3x plus 2, so that means that anywhere that there's a y, I can take it out and replace it with 3x plus 2 because those things are equal. So that's how we're going to go about doing this. So now what you should notice, I'm sorry, I'm losing my voice, is that all I have in this equation are x's. Once I get it down to having one variable only, now we can solve it. So we'll start by distributing 2 times 3x and 2 times 2. So we get x plus 6x plus 4 equals 11. I'm going to combine my like terms. X plus 6x is 7x plus 4 equals 11. And then I will need to subtract 4 from both sides. This is just regular equation solving here. That gives me 7x equals 7. My last step is going to be to divide by 7 on both sides. So we get that x is equal to 1. We're halfway there because now we know what x is, but we still need to know what y is. Okay, so if we look at our checklist up here, we've done step 1. That was to get one of the variables by itself. This one was already set up. Step 2 was to take that equation and substitute it into the other equation. That's what we just did. That's how we got that blue equation, and then we solved it. Now that we found x, we're going to do step 3, which is to take this value of x equals 1 and plug it back into one of the original equations. It doesn't matter which one. I think personally the top one is going to be easier, so I'm going to do that one, but you can do any of them. So we know that y is going to be equal to 3 times x, but now we know what x is. It's 1 plus 2. So that means that y is equal to 3 plus 2. So y is equal to 5. That's our second variable. And now that we know what both of them are, we can write our final answer as an ordered pair. Remember that the order is always x first and then y. So we would write this as 1, 5, and that's your answer. Don't forget the parentheses. Without the parentheses, it's a list of 2 numbers. It's not an ordered pair. Okay? Let's look at example 2. Sometimes it's not going to be set up so that one variable is by itself, in which case you're going to have to go ahead and solve. Now, any of these would be easy to solve for, but what I see right away is that in this first equation, if I were to add y to both sides, I would have x by itself. So if I have x minus y equals 3, I can start by adding y to both sides. That leaves me with x equals y plus 3. Notice this time we're solving for x. You don't have to solve for y every time. You can solve for either x or for y. I thought that the x was going to be easier to get by itself in this one, so that's why I did that. Now, again, what we're going to do is we're going to take this y plus 3, and since that's what x is equal to, I'm going to come to the second equation and put that in here. So this is what that's going to look like. We're going to take out the x, and we're going to put in y plus 3. Then the rest of it's going to be exactly the same. Plus 2y equals negative 6. There's nothing to distribute in front of those parentheses, so we really don't need them. And now we need to combine our like terms. Y plus 2y is 3y, and then we have the plus 3 equals negative 6. Now we need to subtract 3 from both sides. That gives us 3y equals negative 9, and we divide by 3 on both sides now, which tells us that y is equal to negative 3. Again, we're not done, and that's a mistake that I see people make a lot, is they stop there. But we can't do that because now we have to go back and plug in this y equals negative 3 somewhere. You can plug it into any of those equations. You can plug it into the top one or the bottom one, or you can plug it into this one here where we solved for x. I think that one's easier because it's already got the y on the other side. So if we plug that in for y, we have negative 3 plus 3. And negative 3 plus 3 is... When we get 0, a lot of people think that they've done something wrong, but 0 is a number. 0 is a location on the graph. That's perfectly acceptable to have. And so now we just need to write this as an ordered pair. Be careful again. Make sure you're putting them in the right order. X comes first, and then y. So 0, negative 3 would be the point on the graph where those two lines cross. Now, there's 2 more examples in this notes packet that I'm not going to take the time to work through on this video, but if you go on Blackboard, these are worked out in the notes packet that's under the Notes tab for this unit on systems. I would suggest that you open that up and copy these down. If you need extra resources, I would say to go to YouTube and search for Systems by Substitution. You'll be able to find all kinds of things on there. I highly encourage you to work together. Try to help each other out where you can. You know that helped us a lot when we did the flipping unit, to be able to talk about it and work together. So please feel free to work together in groups and help each other out. I will see you guys tomorrow. your assignment is posted on Blackboard.